This video will be on single dominant epistasis. So what exactly is epistasis? Well, epistasis is defined as the expression of alleles at one locus masking or modifying the expression of other alleles at another locus. So multiple different genotypes are going to lead to the same exact phenotype. There are many different kinds of epistasis, but in this video we're just going to talk about single dominant epistasis. Single dominant epistasis is defined as if capital A is epistatic to capital B and lowercase b, then capital A blank will result in a particular phenotype no matter what is at the capital B lowercase b locus. This means that in the normal Mendelian ratio of 9 to 3 to 3 to 1, the single dominant epistasis ratio will actually be 12 to 3 to 1. So let's look at an example using flowers. In a cross between these two parents, these are all the possible alleles that we get, and crossed against each other in a Punnett square, these are all the possible genotypes we get for the F2 progeny. And this gives us the Mendelian ratio of 9 to 3 to 3 to 1. However, with single dominant epistasis, this ratio changes into a 12 to 3 to 1 ratio. And that's because the capital A allele codes for an inhibitor that can stop the enzyme from turning from red into blue. So these two have a capital A allele. No matter what the B allele is, because big A is epistatic to B, no matter what the B allele is, if there is a big A, the flower will not be able to turn from red to blue. So that means that there are 12 red flowers in this cross. And then we go to the little a. So the little a is going to allow the flower to turn from red to blue because the inhibitor won't be allowed to function. So the flower will turn from red to blue, and then if there's a big B, enzyme 2 will be able to function, turning the blue flowers into purple flowers. And then if we have a little a allele, the inhibitor will not be able to function, the flower will go from red to blue. And if we have a little b allele, that will not allow enzyme 2 to function, and the flower will be stuck at this blue intermediate. And across between these two parents, these are the different combinations of alleles. And if we put that in a Punnett square, it will look like this. And that will give us a ratio of 2 to 1 to 1 with 2 reds, 1 purple, and 1 blue.